this would be here. Vector base. Again, just like before, consider this reference frame. Okay? Yes. X, Y, Z. First one, another one.
We need a universal way to let people know when you get here. This whole 15 to 20 to 30 minutes after the hour. Can you just like text everybody for 5 minutes out?
All right. Let's see. So what does this tell you? Gravitational attractions or gravitational
When you have two masses in orbit that they attract each other.
in terms of progressing in the course, what can you infer from that?
What can we infer from that?
It's governed by the law of gravitation.
Try a little more.
That the force between the two, just from the
Until now, what have we been discussing?
The initial flame.
Right. So what is that part? What is that section of dynamics? That was kinematics. This is because now we are introducing force. Now we are talking about kinetics. So there is, if you look at kinematics, does not have any law as such, right? It is just visualizing something in a particular reference. It's realizing motion or visualizing something or measuring position, velocity, acceleration in a particular reference. Okay. This now you start discussing the actual laws. Okay. We did introduce Newton's first law and second law, Newton's second law and Newton's law of universal gravitation. But most of the discussion was reference frames and how to calculate position, acceleration, velocity. Right? So M1 and M2 are the two masses. R1 and R2 are position vectors. M1 and M2. G is the center of mass of this two-body system. and RG will be position vector of DG. This is R2 minus R1 and U unit vector in our direction is R over. You should understand why it is capital R2 minus R. Why is it capital R2 minus R? Why is it not R1 minus R2?
So that's a negative.
You use the parallelogram law of vector addition or vector multiplication. Sorry, vector subtraction. So in this case, R2 plus R1 is equal to, sorry, R2 plus capital R is equal to R1, right? So is this right in this case?
No.
Hmm?
No.
It is right, because this is R1.
Yeah, I don't know what you're saying. Yeah, something wrong.
So R1, R2, R1 plus R is R2, or R is equal to R2 minus R1. Okay. How do we quadratize R? R1. R1 is xi plus yj plus zk. We all know this formula. How do we calculate the center of mass or center of gravity? Hmm?
R squared. No, M is
G
M1
1
No, that is not center of mass. That is the universal law of gravity you are talking about.
It's central, so it's it's area. So what Google's for. Oh, between the two orbiting bodies.
Not just two bodies, any center of mass for any body. This is how you would calculate. Okay? You would just you from a particular distance. This is the distance from the position vector of the center of mass. So this is how you would calculate. Okay? Now, Vg is alright. Let's do this with me, or just pay attention here. So what is Vg? drg over dt, right? Which is what we said, rg circle dot plus omega constant r. Right? This thing is 0. Why is this 0? So you see this, that means this is the inertial frame. It means this, there is no angular velocity, it is fixed. So you have to just take the local derivative of this. Okay? So you're going to get M1 R Do we need to take the product rule here? We do?
No.
We have to take the product rule, but so what happens if we take the product rule? How do we take the product rule? Huh?
The bar,
Huh?
Wait. Hold on. You trying to trick it. You don't need to say, it's mass though. It's mass is.
You could take it, but so this is d over dt of m1 r1 plus m2 r2, right?
Whenever you take the derivative of the masses, you're going to get zero. So that will
Since the masses are,
fixed.
we don't deal with changing masses.
Right.
So mass is constant. Otherwise, we would have taken it first a quotient rule, right?
Yeah. You have to get that
Quotient
out.
rule, and then you would have taken product rule inside. But what happens here is this m1 and m2 are not changing; they are constants. So you just have 1 over m1 plus m2, right? m1 r1 dot plus m2 r2. And this would just be 1 r1 dot. This is Vg. Now Vg. Vg is similarly m1 r1 double dot plus m2 r2 double dot over m1 plus. This is the absolute velocity. This is the absolute position. This is the absolute acceleration.
Put that in the conversation. Absolutely.
What does absolute mean?
In reference to the inertial current.
Right. So everything is measured in reference to the inertial current. Okay.
What is RG again?
Huh?
What is RG again? What is that?
Rg is the position of the center of mass or center of gravity. Center of gravity and center of mass are the same, right, of the system? Center of gravity is what? It's a point where the gravity affects, or you can assume that is where it affects. Center of mass is that point. So you can say,
that's double dot,
huh?
that's double dot.
Yeah, both of them are double dot. You have R is R2 minus R1, you can simply say this is X2 minus X1 I plus Y2 minus Y1
So anybody here that don't do the day this morning?
What is this law?
Meaning law of gravitation.
Right. So what does it say?
Force is gravity.
Huh?
Force is the M1 at charge 2.
You have to clearly understand what F12 means. Okay. It's not the same as F21. So the force of attraction on body
On body 2.
because of body 1
Yeah.
is, this will define that force of attraction,
Yeah.
the unit vector. Okay.
It will coordinatize it.
Is everybody clear on this one?
Can you repeat that one more time?
So the force of attraction if you're talking about body M2, the force of attraction of this body is in what direction? It's in the other direction.
It's pulling mass to
It's
that.
pulling. The force of attraction on this one because of this one is in this direction.
Yeah.
The force of attraction on this one because of this one is in this direction. And that is what that indicates. The force of attraction on body 1 because of body 2.
That's the second part.
This one, what is this? What is this?
Yeah, of course.
I mean, the M R, you pointed out that.
What is this?
That's the force of attraction.
What is this?
That's Newton's second law.
That's Newton's second law.
Sorry, we were trying to look for your answer to the thing.
This is Newton's second law, okay? So you would have had M1 d over dt of R1 dot, right?
Yeah.
But M1 does not change, or d over dt into M1 R1 dot, MV, correct? But this, it just turns out that mass does not change, so that is what you have. Now if you combine these two, this is what you're going to get.
What if the mass is changing?
Huh?
What if the mass is changing?
It will change. It will, the law will have a change in, so when your rocket is going up, why do you think it goes up?
Oh, you don't know.
Huh? So yeah, it changes in mass. So there is change in mass that creates a force, a thrust. Right?
It's displacement of mass that causes thrust.
You cannot, the initial thing is, so it thrusts and there's equal and opposite reaction, right? It takes off. But then when it is in the air, there is no equal and opposite reaction. It has to be mass change. So there is a force created because of mass change. So in which direction is the mass changing? Figure-
Mass is being displaced down, the mass change vector is going up. Thus the rocket goes up.
The MV component actually becomes 0 at that point.
Actually, that's a trick question. It's equal and opposite reaction.
Okay?
This is a reaction. This is an action force like a reaction force.
Erase this part.
No,
This is before.
yeah.
Huh?
Erase that.
We need this.
I need that.
We need a picture.
Right.
I have to just move this again.
You finish writing.
Huh?
You finish writing.
Are these actually going on YouTube?
I haven't seen the YouTube yet. I saw that link.
Those are the day, right? Michael Foster, a white guy, I know white people in here. A white guy tackled a 62-year-old black man going to the ball because he was carrying a concealed handgun. put him in a chokehold and took him down to the ground, because he looked, quote unquote, suspicious. Because I thought it was hilarious. It's another English gentleman case. This guy's being a vigilante. Just let it out before you pop with blood vessel. In terms of, you'd be doing your hand a favor if you sneezed into it. I'll clean it up for you. I highly doubt that. Just the fact, you open the door on the way in, right?
Well, that's
That's, no, not this door, the door outside, in the building.
If we are expressing the same thing for mass m2, it's going to be m2 r2 double dot is equal to minus g m1 m2 over r square. Okay.
Oh, you thought I was talking to you?
No, I didn't go that. Sorry.
Oh, come on, that's last
That's
year.
That's what
I've never gotten mustache. It's going, I'm trying to see my hand apart. Like, I heard my bike, yeah. I like to be convoluted. It's,
So if you take this equation, guys, if you take this equation and you add this, take this equation and add them together, this is what you're going to get, right? Hmm? Now, take a look at this. All right. How did we define Rg as m1 r1 plus m2 r2 over m1 plus m2, and Ag was that, right? What do you get from these two?
The force of attraction between from 1 to 2 and 2 to 1 is equal.
Just look at it carefully. Okay? Huh? This? Right. So if this is 0, what does it mean? If A is 0, A of G is 0, how do you read this? How do you put it in words? How do you explain it to somebody that A of G is 0?
The acceleration of the center of gravitation is 0.
0. Okay. What does that mean?
That means you're in an inertial reference frame.
The center of
Fall into.
the center of mass or center of gravity is a inertial point.
An inertial point.
It's a non-accelerating point. You don't get confused between inertial frame and fixed frame. Okay. Inertial frame need not be fixed.
Inertial is
An inertial frame is something which is
Not accelerating.
non-accelerating frame. Okay. So what this proves is your center of mass of a two-body system is a inertial point. It moves with constant velocity, no acceleration. So that means you can, what does, so you can practically apply all your Newton's laws at this center of mass of any two body system. Okay? Alright, I think we'll stop here. Your test is coming up. The 4th of February, that's what you wanted your test to be. A lot of the material for first test will be out of chapter 1. Okay, it will be a lot of vector operations, vector understanding, and some of this.
Is this not spilling into chapter 2?
This is chapter 2.
Okay.
So that's what I told you. When first chapter was all about kinematics.
Kinematics.
This is now we are starting to deal with. We are trying to understand the motion of two bodies when they are subjected purely to forces of gravitational attraction. Okay, that's what. This is the first thing we proved. So this could be an exam question. Prove that the center of mass of two bodies under pure gravitational forces is an inertial point, or that point is moving with a constant acceleration. So you should go through. You should be able to go through all this derivation. Okay.
But you said for what example?
The question will be, prove that the center of mass of two bodies subjected to gravitational forces only is a non-accelerating point, or is an inertial point. Okay. What is the difference between an inertial point and an inertial frame? How do you define an inertial frame? What is a frame?
Yeah.
This one,
Cube.
No. What is a frame?
It's an outline.
A frame is essentially a plane.
Yeah.
Think about a plane. Okay.
Outline.
So what is a plane? How do you define a plane?
3 points.
Three?
Like two or more.
It's 3 points.
Three what points? Three non-collinear, right? They cannot be linear.
Oh yeah, non-collinear points.
They cannot be collinear. Three. So the reference plane is defined as something which is a reference frame. If you want to define a reference frame, you need 3 points. Okay.
The cross product of the
You don't need a cross product. You just need three non-collinear points. That is a reference frame. Reference frame is essentially just a plane.
yeah.
Okay. Now, what happens when to the reference frame? The condition is the distance between any of these points is not changing as time progresses. If the distance between them changes, that is not a reference frame.
Right.
Because then it changes, right? That reference frame is changed.
Yeah.
So what is the inertial reference frame? Non-accelerating. So when all these points are moving with a constant velocity, that is an inertial reference frame. If all these points are accelerating, then it's a non-inertial frame. Now, how do you go from from reference frame to coordinate systems? What is the difference between a reference frame and a coordinate system? What is fundamental difference?
Unit vectors.
Unit vectors. But what is a coordinate system? And coordinate system is a measurement system.
Which units to do?
Yeah, it's a units. It puts units. Reference frame, you cannot measure anything. Can you measure anything in a reference frame? So coordinate system is a measurement system. When you take a reference frame, right? You put a coordinate system on that reference frame.
Yeah.
Okay, for reasons of measurement.
Sure.
Coordinate system by itself is not inertial or non-inertial. Reference frames are inertial or non-inertial.
So, yeah, because you can't measure it, you can't quantify the, yeah, okay.
And coordinate systems can be Cartesian, polar, spherical, all those. Okay.
I see some true false